Hello guys and welcome back to Math Tutorials. Today we're doing a quick refresher on implicit differentiation. So what is regular differentiation? Well, that's when you have something like y equals, 3x squared and you want to find how y changes in terms of how x changes, right? So you do d dx and you d dx, right? Because we're looking at the change in x and how this is affected. So then we would say dy dx equals, and I'm not going to go through all this, but it'd be 6x, right? And that's from the power rule, and you can watch one of my previous videos on that. But what if we have something more complicated, right? What if we have something like this, and we still want to find dy dx, right? But we're not really given y equals, right? We don't have that. We just kind of have x and y. They're not really separated. This has got to be like post-segregation or something. Um, but it's a bit more complicated. So what we can do is we can pretty much just differentiate both sides. So I guess I'll write this out. So really there's only two main steps. Differentiate both sides and then solve for dy dx. So this is just going to be using whatever differentiation rules. So pretty easy. And then this is also pretty easy. This is basically just algebraically like getting combining like terms basically is what it is, and getting dy dx by itself on one side. So neither of these should be too difficult. So let's look at this problem. X to the third times y to the fifth plus 3x equals 8y to the third plus 1. Okay, so I guess I should like write this out, right? X to the third, y to the fifth plus 3x equals 8y to the third plus 1. So as always with these videos, the goal is not to give a detailed explanation. The goal is kind of just to do a quick little refresher and hopefully jog your memory for this next upcoming year of math. So let's differentiate each term, right? Because we're going to do, dy, or no, d dx on both sides. And this is actually important, right? We have to realize that what we're doing is we're finding the derivative in terms of x, which means that the derivative of x, right, d dx of x equals 1. So if we ever have to do, that, we can just replace that with 1. But if we have d dx of y, that is not equal to 1. That equals just dy dx, right? And this will come up a lot in some like chain rule type stuff. But if we start here, to differentiate this, we'd have to use the product rule. So the derivative of 3x, or x to the third, is 3x squared times y to the fifth, and then plus the derivative of this, y to the fifth, which is 5y to the fourth. But really, this is a chain rule because y is already a function of x, presumably, maybe, kind of. But y is already a function, so we have to do this times dy dx, basically. If you want to think of that as, like x times f of x or something, to make it easier. But basically, since we're doing the derivative in terms of x, we don't have to do it with this, right? We don't have to do 3x squared dx dx because dx dx is just 1, but we do have to do it for the y. So we have this, and then times the x to the third, and then plus the derivative of 3x is of course just 3 equals, due to the power rule, but also chain rule, 3 times 8, 24 y squared dy dx plus the derivative of 1, which is 0, so I'm going to leave that off. So now we have this. So this is our kind of derivative looking thing, but you notice we only did the first step, right? We differentiated both sides. It wasn't that bad. It kind of looks a bit, scary, but now we have to solve for dy dx. Now usually you're going to have at least one dy dx term on this side and one on the other side, and we do indeed have that here. So basically the strategy is going to be subtract this on both sides to get it over here, and then get all the other stuff, this and this, over there. That's going to be the strategy. And then we're going to have, something dy dx minus something dy dx, and then we can factor out the dy dx and then divide by the thing. So let's just do it, right? So we're going to keep this. So we're going to keep the 5y to the fourth dy dx. We're going to get this on this side. So minus 24y squared dy dx equals, and get everything else on the other side. So minus 3x squared y to the fifth, and then minus 3. Okay, so now we can factor out the dy dx, right? We're going to factor that, and there's going to be something in here, and then we're just going to divide by this parentheses on the other side. So, of course, the first term is 5y to the fourth. The second term is minus 24y squared, right? Simple factoring out. And then this side remains the exact same. Then what we do is we just simply say dy dx equals this part, the part that's already on the right side, which was, remember, every term that did not have some sort of dy dx in it. And then you are dividing by the left side, so minus 24y squared. And this is our derivative, which, it doesn't look great. Let me just double check, because I do in fact have the answer right here. Oh, interesting. Oh, okay. Yeah, there's the same, just everything is, yeah, the top and bottom are just multiplied by -1. But this is the right answer, is what that means. So, you can see it's not too complicated of a process. It's just that there's a lot of algebra involved. And in fact, I'd say that's really the hardest part is just like the algebra involved. I mean, I guess like if you're not solid on your differentiation fundamentals, that part can be hard. But realistically, it's just going to be a bunch of probably product rule, quotient rule, chain rule, power rule, like just the four basics. And then the algebra can kind of trip you up. But overall, I'd say this isn't too hard of a process. You're going to get this a lot when you have problems like you have a balloon and you're filling it up, right? Because it's going to be like volume equals some, x whatever, r whatever, some function of x and r or whatever, and you're going to want to find the derivative of this and how it relates to the change in, r, stuff like that. So you're going to have a lot of those problems, especially word problems. For the regular problems, non-word problems, you're just going to get a lot like this. Just straight up, here's a bunch of stuff and differentiate it. And then what you could actually do from here is you could find the second derivative as well. You would have to find the derivative of this, which is going to be in terms of x, y, and dy dx, right? When you try to differentiate this right side, you're going to have some dy dx is still in there. And then what you can actually do is just everywhere you see this, just replace this whole thing. And then it's just and then because this is already in terms of y and x, you're going to get rid of these and it's still just going to be x and y. So if you need the second derivative, you can do that, which I've had to do. It kind of sucks, but it's not, I mean, it is kind of bad, to be honest, it sucks. Um, but it is possible to find a second derivative with this method as well. And yeah, hopefully that kind of just jogged your memory on how to go back through something like this. Like I said, not a full explanation, but hopefully enough to kind of remind you what implicit differentiation is, because that's a lot of the struggle when you go into a new school year, is just like seeing a term and being like, I think I knew what that was at one point in my life, but I no longer have any idea. And implicit differentiation is two big words. Right? That's like multiple syllables. So I wouldn't be surprised if someone sees that and gets scared. But it's pretty simple and very useful. You're going to see it a lot, probably. So thank you for watching. If you have any questions, leave it in the comments, and I'll see you next week. Oh, I guess I should talk about what I'm going to do next week. Again, kind of unprepared for this, not going to lie. Let me see. Implicit differentiation. Related rates. That's basically just implicit differentiation, to be honest, but with like formulas. Sure. Let's do the next time on mathematics tutorials. We're going to look at the mean value theorem, because I think that was pretty important. Also, Rolle's theorem. I don't even know what that is, but maybe that'll be important. So we're going to look at that. All right. So thank you for watching, and see you guys next week.